awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. So now let's continue example 6 for the revision. Kita baca soalan dulu. A tub in a washing machine goes into its spin cycle starting from rest. So saya highlightkan starting from rest means that omega naught should be equal to 0. Okay? And reaching an angular speed omega 15 radian per second in 8 seconds. Okay? At this point, the person doing the laundry opens the lid. Okay? So ini adalah case pertama lah. Okay? Dia tengah berpusing kan? In 8 second, okay? Dia tengah spinning. Okay? And then what happens? Suddenly, a person opens the lid and a safety switch turns off the washer. Okay? So suddenly, dia akan turn off lah. So the tub slows to a rest in 12 seconds. Okay? So kita akan pergi kepada case yang kedua. So second case, okay, means that, okay, omega here. So saya akan letak sini adalah omega 1 and this should be omega naught lah. So omega naught 2, second case, should be 15 radian per second. Okay, and then omega 2 should be 0. Okay, they're slowing down dalam masa 12 seconds. So T2, yang ni kita letak T1. Assume a constant angular acceleration as the tub is starting and stopping. So maknanya constant angular acceleration masa dia accelerating untuk case 1 and then this is decelerating untuk case 2. Okay? So this one should be alpha positive. Okay. Accelerating constantly. Okay. And this one, alpha is negative value. Okay. Decelerating constantly. Okay. So positive, negative. Alright, okay. So A, through how many radians has the tub rotate during this time? Means that theta, okay, the total angular displacement, okay, from case 1, masa dia tengah accelerating, plus dengan masa dia slowing down and decelerating, masa orang tu cuba buka lid washing machine tadi. Okay. So kita boleh kira lah. Kita boleh kira case 1 dulu. Kita mulakan dengan case 1. We want to calculate alpha, right? So omega 1 is equal to omega naught 1, okay, plus alpha t. Okay, so now let's substitute 15 equal to 0 plus alpha 8. Okay, so since the machine is accelerating, so alpha must be positive value. And it is equal to 1.875 radian per second negative 2 per second squared. Okay, boleh. And then kita ada alpha 1 for case 1. And then for the second case, let's write omega 2 equal to omega naught 2 plus alpha T2. Okay. So, let's substitute final velocity for the second case, masa dia slowing down. So, it is equal to 0. Omega naught should be 15. Okay? Sebabnya ceritanya macam ni lah. Kalau kita lukis, starting from omega naught, 0. So, apa berlaku? Ini dia accelerating selama 8 second. So, omega 1 here. So the final velocity should be 15 radian per second. Tapi from here to here, omega 2, which is 0, they're slowing down. Okay, so dia punya timeline macam ni lah. Ini speeding Okay, speeding up. This one should be slowing down. Okay, speeding up ni kita dah kira lah alpha dia is equal to positive 1.875. Okay, radian per second squared. Okay, so alpha 2 ni kita kena kira jugalah. Okay, kita kira. So, plus alpha T2 dia akan berhenti selama 12 second tu daripada 15 radian per second. So, dia akan berhenti jadi 0 radian per second dalam masa 12 seconds. Okay, so alpha you akan dapat nilai negatif 1.25 radian per second squared. Boleh Okay, so sekarang kita nak kira total. How many radians means that we want to calculate the total displacement in radians unit. Okay, so saya akan kira dulu. Okay, theta 1 saya berapa? Okay, maknanya daripada sini, daripada point A pergi ke point B, berapa dia punya angular displacement. So kita boleh guna formula omega 1 squared equal to omega naught squared plus 2 alpha theta 1. Okay, saya letak 1 semua tu untuk case 1 lah. Okay, so just substitute all the values. This one should be 0, right? Plus 2 alpha kita dah kira tadi. So selama 8 second tu berapa theta 1? So kita boleh kira. Okay, it is equal to 60 radian. Okay, so itu belum jawapan lagi. And then kita boleh kira pula theta 2. Okay, theta 2. Okay, sama juga formulanya omega 2 squared equal to omega naught 2 squared plus 2 alpha 2 theta 2. Okay, for the second case. So we can substitute. So finally the machine will stop. So omega 2 is equal to 0. Okay, and then omega naught 2 15 squared. Okay, daripada sini lah, daripada sini ke sini tadi. 15 to 0 radian per second. Okay, plus 2 alpha tu kita dah kira, negatif jangan tertinggal, negatif 1.25. Okay, times theta 2. Okay, saya gerakkan sikit ke sini. Tak muat nak tulis. Okay, so therefore theta 2 after calculation, okay, we substitute all the values correctly. So you akan dapat 90 radian. So daripada point A pergi ke point B and sampai ke point C where the machine stop bila orang itu cuba buka dia punya lid of the washing machine. So daripada A, B, C, how many radians has the tub rotate during this time? So means that we want to calculate the total angular displacement is equal to theta 1 plus theta 2. Okay, so it's equal to 60 plus 90 and the answer is equal to 150 radian. Okay, so ini dalam unit radian lah untuk soalan A. Dan soalan B dia tanya pula how many revolutions did it make. Okay, so B lah. B tukarkan saja 150 radian kepada revolution. So, 1 revolution, partner radian mesti duduk bawah. Okay, ini dekat atas, partner dia duduk bawah. So, bahagi 2 pi radian. Okay, so therefore, the number of revolution should be equal to 23.87. Okay, revolutions. Okay, so finish example number 6. Okay, now example number 8. Sebenarnya selepas example 6 patutnya 7 kan? Okay, tapi dia terus jadi example number 8. Okay, tak apalah. Okay, so the wheels of a bicycle make 30 revolutions as the bicycle reduce its speed uniformly from 50 km per hour to 35 km per hour. Saya kalau nampak kilometer per hour ni, mata macam sakit je kan. So, kita kena tukarkan dulu kepada meter per second. Okay, dia rasa macam tak kena kan. Sama juga macam revolution. Kita tahu 30 revolutions is referring to the angular displacement. So, we need to change to radian unit first. Okay, so kita tengok pada speed dia dulu. Okay, since given that U is equal to 50 kilometer per hour. Ini chapter 1 ni. Okay, you kena tahu bagaimana nak tukar kilometer duduk dekat atas, partner dia duduk dekat bawah. So, 1 kilometer is equal to 1,000 meter. So, kilometer saya cancel. Lepas tu, hour pula kita nak tukar. Hour duduk dekat bawah, so partner dia duduk dekat atas. Hour nak tukar kepada seconds. Okay, so 1 hour, 3,600 seconds. Okay, betul. 1 hour, 60 minit times 60 seconds, so 3,600 seconds. Okay, so U kita akan dapat 13.89. Awak cuba kira ya. Okay, practice tekan calculator. And then V, 35 kilometer per hour, sama jugalah, times 1,000 over 3,600. Okay, so kita akan dapat 9.72 meter per second. Okay, so betul lah. Okay, U lagi besar daripada V. Okay, maknanya speed dia berkurang Okay, and the angular displacement theta. So, let's write theta given in revolutions unit, 30 revolution. I want to change to radian. Okay, so revolution dekat atas, partner dia dekat bawah. Revolution nak tukar kepada siapa? Kepada radian. So, 1 revolution is equal to 2 pi radian. So, we cancel out. So, theta, you akan dapat nilainya adalah 188.5. 188.5 radian. Okay? Jadi, apa lagi maklumat dia bagi? So, the diameter is given 70 centimeter. Okay, make sure you change to meter lah. And bahagi 2, ini diameter. So, radius should be 0.35 meter. Okay? So, finish. Okay, ini kita dah settle. Kita boleh jawab soalan lagi kan? Kita baru settle. Tukarkan semua tu. Okay. So, now A. Calculate the angular acceleration. So, we want to calculate alpha. Kan? Angular acceleration. Tapi maklumat yang kita ada kat sini, U, V, ini angular displacement. U adalah linear. Okay, linear speed dia. V pun sama. So, kita nak cari alpha. So, tak nak kita kena tukarkan daripada U, from information U ni tadi, kita cari omega naught, and from V, kita cari omega. Okay, so kita kena tahulah relationship antara U dan omega naught, where U is equal to R omega naught. Boleh? So, omega naught is equal to U over R. So, U is 13.89. Wajib tukar kepada meter per second. And R is 0.35. Okay. So, omega naught 39.69. Okay. Radian per second. Okay. Sekarang omega pula. Iaitu final angular velocity. So, V is equal to R omega. Omega is equal to V over R, where V is 9.72 over 0.35. Okay? And then the final answer should be 27.77. The final angular velocity. Okay. Soalan suruh kita cari angular acceleration. So, now we can substitute dalam equation rotational kinematics. Iaitu formula apa kita nak pakai? Alpha, kita ada omega, omega naught dan juga theta. So, I will use omega squared equal to omega naught squared plus 2 alpha theta. So, based on the information that we have, we can substitute first. Okay? And then, we can find what is alpha. What is the value of alpha? Okay, pastikan tekan kalkulator elok-elok. So, you akan dapat alpha mesti negatif lah. Okay, kenapa? Sebab dia slowing down. Okay. Okay, the wheels is slowing down. So, negative 2.13 radian per second. Okay, kalau you tak dapat negatif tu, salah lah maksudnya tu kan. Okay. So, B. Sekarang kita nak buat B pula. Sekejap Saya buat garisan dulu. Okay, now B. Okay, If the bicycle continues to decelerate at this rate, determine the time taken for the bicycle to stop. Okay, maknanya dia tanya kalau dia teruskan lagi decelerate. Okay, so for B, so we know that alpha is equal to negative 2.3. Jadi kita lukis dulu timeline dia. Maknanya daripada point A. So here let's say 13.89 radian per second. It's moving until point B. Let's say dekat point B, dia punya omega, angular velocity at point B, reduce until 9.72. Okay. And then from B to C. Okay. From B to C. C ni kita assume lah ini dia akan stop 0. So if the bicycle continues to decelerate at this rate tu referring to the angular acceleration lah. Okay. So determine the time taken for the bicycle to stop. Maknanya masa yang di continue tu tadi. Ini. Kalau di continue, berapa masa yang diambil untuk dia berhenti? Okay. T dia berapa? T here. Okay. So now we can calculate what is the time taken for the wheel to stop from B. So from B maknanya ini dia punya initial angular velocity and this is the final. Okay, so omega C final equal to initial at B. Okay, plus alpha T. Kita guna tu. Kan? So omega C 0, omega B is 9.72 plus alpha kita dah tahu tadi T. Okay, so therefore T is equal to 13.04 second. Okay, that's mean the time taken for the wheel to move from B to C, daripada B dia keep on slowing. Okay, so sampai dekat point C dia berhenti. So berapa masa yang diambil kalau tayar itu still berpusing pada kadar yang sama, dia still decelerate at same rate, negative 2.13 radian per second squared. So masa yang diambil untuk berhenti daripada B ke C is 13.04 seconds. Okay, so finish example number 8. So let's proceed to example number 9. Okay, example number 9. So this is very simple. So here we have an equation of angular displacement. Okay, and the equation as shown here. Okay, so where theta is in radians and t is in seconds. Determine the angular displacement. So we want to find what is theta, angular displacement, angular speed, and also angular acceleration at t is equal to 3 seconds. Okay, so this is very simple. So we can find what is the instantaneous angular displacement at t is equal to 3 seconds. So we can find what is the instantaneous angular speed at t is equal to 3 seconds. And also what is the instantaneous angular acceleration at t is equal to 3.0 second. Okay, so we can find first what is the angular displacement. So at t is equal to 3 seconds, theta is equal to 5 plus 10. T tu gantikanlah 3 plus 2, 3 squared. Okay, substitute and then kira lah. So theta you akan dapat 53 radian. So dia tak minta jawapan dalam revolution, kan? So dia dah bagi tahu unit untuk equation ni tadi adalah radian untuk angular displacement. Okay, and at t is equal to 3 second, so we can find what is the angular speed omega by differentiate the equation of angular displacement theta. Okay, so it's equal to d dt 5 plus 10t plus 2t squared. Okay, so bila kita differentiate equation angular displacement, so after differentiate the equation, so we have 4t plus 10. Okay, so we can substitute. So saya sambung dekat sebelah ni. Omega is equal to 4, t is 3 seconds plus 10. Okay, so omega is equal to, okay, berapa dapat tu omega? 12 plus 10, so it should be 22. Okay, radian per second. And the last one, how about the acceleration? Okay, so angular acceleration, we can differentiate equation of omega. Okay, so d dt, so the equation of omega is 4t plus 10. Therefore, okay, alpha is equal to 4. Okay, itu saja, tak ada in terms of t. Means that at any time, t equal to 4 second ke, t equal to 5 second ke, okay, angular acceleration dia tetap 4 radian per second squared. Okay, maknanya kalau soalan suruh awak kira what is the angular acceleration at t is equal to 10 seconds, for example, kan, jawapan dia tetap samalah, kita tak boleh pun nak substitute nilai t. Okay, means that the angular acceleration is constant untuk case soalan ini. Okay, so ini semua jawapan yang kita dah dapat tadilah. Alright, so finish example number 9. Alright guys, the last example, example 10. Okay, sebenarnya example 9 ni, saya tertinggal example 7. Okay, tak apa, kita buat 9 soalan saja untuk video yang pertama. Okay, tak apa, kita buat saja 9 soalan untuk subtopik ini. So, let's read the question first. A rigid body rotates about a fixed axis through a point in the body with uniform angular velocity of 600 revolution per minute. Okay, so given that omega naught is equal to 600 revolution per minute. Okay, revolution per minute ni bahayanya. Kenapa? Kalau awak tak tukar kepada radian per second. So, partner dia duduk atas, tukarkan kepada radian. So, cancel revolution. 1 revolution 2 pi radian. Sekarang kita nak tukar minit pula. Minit kepada seconds. Okay, so minit duduk bawah, partner dia duduk atas, tukar kepada seconds. So, 1 minute 60 seconds. So, minit ni boleh cancel. Okay, so omega naught, okay, so omega naught is equal to 62.83. 62.83 radian per second. Okay, and then what happened to the body? Okay, the velocity then decreases at a constant retardation to 300 revolution per minute. Okay, so determine the angular acceleration. Macam lebih kurang sama kan dengan soalan tadi pun. Okay, kita boleh kira dulu 300 revolution per minute. Okay, times 2 pi radian. And then this is 60 second. Okay, you kira lah. Nanti you mesti akan dapat 31.42 radian per second. Okay, so t is given in 6 seconds. Alright, so now you want to calculate the angular acceleration. Okay, so saya hanya gunakan formula ini sahajalah. Okay, so the velocity is decreasing, means that the value of alpha should be negative value. So omega is 31.42, omega naught is 62.83, plus alpha nak cari 6. Therefore, alpha is equal to negative 5.2 radian per second squared. Unit jangan salah. Okay? And then B. So B, the number of revolutions the body has turned through in the 6 seconds. So kita nak kira theta. Tapi theta yang kita dapat nanti, unitnya mesti dalam radian. Tukarkan kepada revolution. Okay, so saya gunakan formula ini sajalah. Very simple. Okay, so we want to calculate theta. So 31.42 squared jangan tinggal. 62.83 squared plus 2. Alpha is negative 5.2 theta. Therefore, theta is equal to 284.65 radian. Okay, tapi soalan bukan nak dalam radian. Make sure you change to unit revolution. Okay, so radian. So radian duduk atas, partner duduk bawah, nak tukar kepada revolution. 1 revolution equal to 2 pi radian. So maknanya kena bagi dengan 2 pi radian. Okay, so theta you akan dapat 45.3. Okay, revolutions. Okay, so finish B. And then how about C? Okay, C. The extra time needed by the body to come to a stop if it continues to slow down at the same rate. So, sama macam soalan washing machine tadi kan? So, alpha is equal to negative 5.2. Okay. So, means that kalau kita lukis dia punya timeline from A pergi ke B and then dia akan stop dekat C. Omega C equal to 0. Omega 2 is equal to 31 31.42 radian per second. And omega A, ni tadi omega B. Omega A 62.83 radian. Okay. So from A to B, it takes 6 seconds to slowing down from A to B. Okay, from B to C, kat C dia nak berhenti. Ini yang kita nak cari T2. And dia punya deceleration is constant maknanya sama lah rate masa A ke B. Okay, dia slowing down dengan rate ini. Okay, B to C pun sama. So, saya boleh terus carilah. I want to find T2. So, omega C is equal to omega B initial from B to C. So, omega B plus alpha T2. So, I want to find T2 only. Okay, sebab kita nak cari extra time needed. Berapa lagi masa tambahan diperlukan from B to C sampai di stop dekat point C tadi. Okay, so 0, omega B is 31.42 plus alpha negative 5.2 T2. Okay, so finally T2 you akan dapat nilainya adalah equal to 6 second. So maknanya the rigid body need extra 6 seconds okay, from B to C so that it will stop at point C. Okay, so extra time needed. Okay, T2 is equal to 6 second. Unit jangan tertinggal. Okay? Okay, jadi kita dah siap discuss 9 soalan. Okay, saya memang tulis 10. Tapi rupanya bila kita buat, kita skip. Okay, tertinggal soalan nombor 7. Okay, tak apa. Kita dah selesai discuss 9 soalan. Okay, kita dah discuss 9 soalan dan kita akan jumpa lagi dalam next video dengan subtopik 8.2 equilibrium of rigid body, dan kita akan buat lagi banyak contoh soalan untuk kita practice sebelum awak jawab soalan assignment. Okay, so jumpa lagi. Assalamualaikum dan selamat sejahtera. Bye bye.